Today, we are going to look at rational functions and domain of rational functions. First of all, let's find out what a rational function is. If f of x is equals to g of x all over h of x, where g of x and h of x is a polynomial or a polynomial, polynomials, we say that the function f of x is a rational function. Alternatively, we can also say that a rational function is the ratio of two polynomials. So the two polynomials called g of x all over h of x, the ratio of two polynomials in which the denominator in our case, which is h of x, is not equals to 0. So this is a rational function. Now let's look at the domain of a rational function. Okay, so we look at the domain of a rational function. Now if we have a function, if f of x is given to be x plus 5 all over x minus 2, and we have to find the domain of this function. So we can say that let x minus 2 equals to 0, and solving for 2, x is going to give us positive 2. So we can say that the domain of a rational function is going to give us the value of x such that x belongs to all real numbers. So the set of all real numbers except x is not equals to 2. So we can say that the domain of a rational function is the set of all real numbers except the 0 of the denominator. Now what this means is that we say that x plus 5 all over x minus 2. So if we substitute the value of x, this will give us x plus 5 all over 2 minus 2, and this will be x plus 5 all divided by 0. But we know that this function x plus 5 is undefined. So anytime we have to find the domain of a rational function, we always have to find the set of all the non-zero of the denominator. So the set of all real numbers except the 0 of the denominators. Alright, let's take a look at illustrative examples. So we have here, find the domain of the following rational functions. The first question we have here is f of x equals to minus x minus 1 all over 2x minus 3. So let's go ahead. We say that let's always equate the denominator to 0. Let 2x minus 3 equals to 0 and solve for x. So we are going to have here to be 2x equals to positive 3, and so the value of x is going to give us 3 over 2. So in this case, we can say that the domain of this function is the set of all real numbers except x is not equals to what? 3 over 2. Recall, the domain of a function is a set of all real numbers except the 0 of the denominator. Alright, now let's take a look at the next question here. We have here 6x squared plus x minus 1 all divided by 4x squared plus 4x minus 3. Okay, so we always have to set the denominator to 0. So we say let 4x squared plus x minus 3 equals to 0. And this function is a quadratic function, right? So here give us the term a, and this is going to give us the value of c. So if we find the product of ac, this is going to give us 4x squared times minus 3, which is equals to minus 12x squared. Alright, now we are going to find the product of the factors of this function, or or the root of the function, which is going to give us 4x and minus 3x. So we find it just a way that the product will give us minus 12x squared and the sum will give us positive 1. And this is true because 4x squared minus 3x 4x minus 3x will give us positive x, and 4x times minus 3x will give us what? Minus 12x. So we are going to have here to be 4x squared plus 4x minus 3x minus 3 equals to 0. Now I'm going to factor out things, grouping it, and I will factor it out. So I'm going to have here to be 4x, which is common to both 10, and this will be x plus 1 minus 3 out, and this is going to give us x plus 1 equals to 0. So here we are going to have here to be 4x minus 3, and this will give us x plus 1 equals to 0. Alright, okay. In case you have a function that cannot be factored, you can use the general formula to find the root of the quadratic function. Alright, so this means that we are going to have here to be 4x minus 3 equals to 0, or x plus 1 equals to 0. If we simplify this, it's going to give us x equals to positive 3 over 4, or x equals to minus 1. So we are looking for the domain of this function, the denominator. So this is going to give us the set of all real numbers. So we call this x such that x belongs to all real numbers except x is not equals to minus 1, or x is not equals to positive 3 over 4. Alright, now let's take a look at another example before we bring this section to a close, to an end. So we have here f of x equals to the square root of x minus 3 all over x squared minus 9. Now the function f of x can also be written as the square root of x minus 3 all divided by the square root of x squared minus 9. Okay, so now as usual we say let's set the denominator, or let's equate the denominator to 0, and so we are going to have let the square root of x squared minus 9 be equals to what? 0. Now if we take the square of both sides, okay, we are going to have here to be x squared minus 9 equals to 0, and solving for x, we are going to have x squared equals to 9. Now I'm going to take the square root of both sides, so it's going to give me the square root of x squared equals to plus or minus square root of 9. And so as usual, this is gone again, so we are left with x equals to plus or minus 3, because the square root of 9 gives us plus or minus 3. So in this case, we will say that the domain of this function is such that s belonging to all real numbers, the set of all real numbers except x is not equals to plus or minus 3. So the value of x shouldn't be positive 3, it should also be negative 3. In the next video, we are going to look at how to evaluate polynomials. See you.